Hi, this is Anyi, and I'm a postdoc at Stanford University. Today, I'm going to talk about intelligent tools to support video production. At the very beginning, I would like to talk a bit about the history of videos. The first motion picture is created by Edwards in 1878 at a farm near Stanford. He used multiple cameras to take a series of photographs of a rider on a galloping horse. 10 years later, Lewis made the first video that is shot by a single camera that lasting for 2 seconds. And everybody can also observe that the earliest video is more like experiments to showcase the breakthrough of techniques. The authors doesn't really care about the content within it. After another 10 years, George introduced the concepts of editing. It looks like magic. Or the visual effects shown in the right. These editing concepts have a very strong impact in today's creative video.
So some see this glass as half full, some see it as half empty, but I see it as a piece of cake.
And also, today we have Sora that can generate a 60 seconds multiple shot video according to a single sentence. So as a starting point to study video, at the first year of my PhD, my supervisor told me, hey, Annie, your job is to watch movies. So I watch thousands of movies and build MovieNet, which is a holistic data set for movie understanding. As we thought, movie is a perfect source to understand the story and cinematical parts of video. We analyze its story part and who is doing what at where and when. We also shifted the perspective from audience to creators and provide a new way to analyze movies through its cinematical style. Our holistic computational approach to understand movies provides a key observation and opportunity for us that with the well-development of AI techniques, we can get a multi-model structure understanding of videos. And here is a demo of my favorite movie, Titanic. This method has also found wild domain applications like in Amazon, Tencent, Netflix, and so on. So equipped with such abilities to understand videos, can we further utilize these abilities to help video creation? To answer this question, let's first check out how video is created. Starting from the most straightforward way, since a video is actually a series of image frames and an image is a matrix of pixels. So if we can generate each pixel, then a video comes out, like the opening scene here, and we can further edit it, like the example showing the right. A video can also be viewed as a result of a camera robot navigating in the 3D environments, where the action space is about its position, angle, and the inner perimeters. It's also common in our life that video coming from multi-view footage, like the case in TV shows or in the panorama footage. Then the action space is about which view to use at what time. Furthermore, when we specify the scenario to a more professional video case, like movies, is very comprehensive that is made from pre-production, on-stage production, and post-production. So we know a good movie usually takes several years across thousands of people's work and it combines people's efforts, language understanding, graphics, visions, and more. From all these different perspectives, we may notice that solely relying on human might involve long and tedious modification. Machine alone cannot really create what we need, as it's hard to control, as it's a black box inside, and we do not know what is created. So this leads us to think about the relationship between human and computers. So for the human side, whether we can figuring out the tedious parts and design tools to better align with users' intention, and from the machine side, whether we can make it to be more controllable, interpretable, and explainable. To answer these questions, I'd like to start from pixels. So in the past year, we have witnessed many large-scale image generators, especially text-to-image generation. When we were intended to achieve some goals, we had to iteratively edit the prompts many times. And this process requires lots of trial and error. So to provide a more control to existing text-to-image models, we propose ControlNet, which is a method to add additional controls to large-scale text-to-image diffusion models. ControlNet is a method to control image diffusion model with different conditions, like the edge images, boundary lines, human pose, and so on. This architecture of ControlNet can be seen as three parts: using external control image, reusing pre-trained backbone, and using zero initialized convolutional layers. This kind of design not only can provide or generate beautiful images according to the conditions, but also enable strong abilities to recognize the input conditions. And the system can even guess the content of input images when there is no prompts or insufficient prompts are given. So this kind of like easy to use methods enables creators to unleash their creativity and productivity. Like example showing up here, they can generate beautiful images according to some draw line, according to this pedestrian sign, and according to this logo. With the abilities to generate beautiful images with additional control, can we further think whether we can support it to video generation? To address this, we first propose Animate which is a plugin model that can animate personalized image diffusion models to generate high-quality videos. So its key idea is about designing a motion module that can learn motion priors from data and insert into image diffusion model. With this design, our method is able to generate more stable video while does not require fine-tuning in the inference time. Here are some examples for the Animate diff. Together with the techniques of talking face, it can also support some conversation scene.
You say I'm not being authentic. That's offensive to me.
But you are real.
What do you mean I'm not real?
And also like support some kind of like a special visual effects. And animate diff and ControlNet can be combined together to render this kind of like input conditions. And also like add a different styles to the existing video. And also like support a remixing of real videos and generated videos. It also support like changing to a different styles of the existing like movies. This is an example from Oppenheimer. These methods can also be extended to support some sparse conditions, like some single image, or we given a keyframes of scribbles. But even equipped with such good tools, but we will find it's still hard to tell a good story with all this generative AI. And here is an example of my using animate diff and IP adapters to generate a series of actions like sitting and then standing out up and then leaving out from the door. We find out it's very hard to make the background setting to be consistent, and also it's hard to control the details that I want to make here, like the facial expression. So here is an example, another example of my writing a script and then turning this script. I wanted to turn this script into some visual content. What I do here is I will first draw a storyboard up here. So the story overall is about a boy named Timmy, and then he had an adventure at his bathroom. When he get out his dinosaur toy, and then this dinosaur toy fall into the bath tube, and then the toy become a real dinosaur. So let's compare the difference between my using AI and it's also taking a lot of time using it with the results that I draw in the storyboard. So you can see like in the scene 2 and shot 2, when Timmy get out the toy, the video generation model is hard to understand what happened over there, and it only generates a boy or a man, and then with a dinosaur. And in the next few shots, people, the main character fall into the bath tube, but the video generation cannot guarantee it is still within the tube, and it's not understand this can use an empty shot to describe this kind of behavior. So important observation here is when we check out any two shots with the left results, according to some montage effects by the human, is somehow can be accepted. But the problem here is all these shots, they accumulating a lot of these questions to audience, like why there is a dinosaur behind, why it go to the water. And this kind of questions is not solved in a later shot. So this resolved us to totally give up to understand this kind of video. So why this happens? Because video contains so many rich details and is also like carefully controlled, like the human action and place. So when we back to the examples in Sora, we will clearly see a lot of like this kind of questions within its different shots. Like why this, there is like a table showing up here, why the backup change, and why this like a red jacket woman disappears. So in the second part of my talk, I will briefly cover the rest of parts in this map and discuss if there are any insights that can help us to develop tools that to better support video creation. So jumping out from 2D, 3D presents better controllability and usually binds together with the production flow. To produce a video more efficiently on stage, people usually made storyboards as a pre-production tool to guide the on-stage filming. At its core, it contains character actions and shot scale and shot movement. However, traditional static storyboards lacks abilities to faithfully demonstrate the dynamic content, and it also requires drawing skills and time for artists to make, let alone amateur creators who lack skills. So we developed a virtual dynamic storyboard to enable amateur designers to quickly generate what something in their mind and do a pre-visualization. So the tool takes a formatted story and a camera script as input to generate dynamic storyboards. The tool can clearly show all the character and the camera behavior in the 3D space, and that directly guides the downstream filling. However, its challenges lies in the mismatch of user's mental representation and also the machine's presentation. Usually a creator will describe a shot, like here is like a dolly full eye level. But for machine, it needs the specific space and rotations of the camera. The second part comes out from, we also want these tools to support creators to make iterative improvement. So how to enable these 2 points? So the challenges can be further narrowed down into both the generation and evaluation process. For the first point, the enormous frame-based action space for camera trajectories can easily lead to low-quality shots in terms of the abruptness and less meaningful camera motions. So by specifying shot styles, we raise our manipulation unit from frame to shot and significantly reducing the search space for appropriate camera configurations. And also, like, because there is no universal criteria for generated shots, we resort to a data-driven approach that aims to discover rules from real movie data. With this in mind, our tool first executes the story scripts and analyze the environments and the characters' actions to provide constraints for camera. Combined with the shot style scripts, camera follows the predefined cinematical subspace to produce multiple plausible shots. And the shot ranking network in the end scores this generated proposal and assists user selection. So through our user study, we're figuring out with this tool for the storyboard designers, it can easily make iterative improvement and then get a pre-visualization of what they want. And also like for the downstream storyboard user, like the director and the photographer, they're also figuring out this kind of like standard process facilitate downstream creators. But from another perspective, referencing the character and the camera behaviors in the existing movie is commonly used in practical filming production. So what we need to do here is we need to first extract the camera and the character behaviors and then put into whether transfer into 2D or transfer into 3D. Here is the example of La La Land. This is the original shot. And then we can extract its foreground and background and applying mask over there. And then we can further change one of the characters to the characters that we want. Like we change the Anna to a character that we like here. So the way it works is like it firstly applying SLAM techniques to estimate its simple tracks in the world coordinates. But more importantly is to taking NERF as a differentiable renderer to provide image level matching supervisions to further optimize the camera trajectory. So here are more examples of that. About the interaction example, also like a multiple perspective. But sometimes, especially in our real life, it's not so easy to capture 3D. So we study a fake 3D captured by 360 cameras. Our tool allows users to generate desired normal view videos in the post-processing. Traditional methods need to specify the field of view for each keyframe, which is time-consuming and intimidating to the common user, while our tool provides more user-friendly control on the semantics and the cinematical styles. And in the end, the system is also able to provide specific feedbacks to the users. And here is the implementation of our approach in the interactive tool with control and explainable feedbacks showing the right button. This tool is also verified by a detailed user study among professional and non-professional groups. And both groups agree with its high quality to enable to mitigate the gap about users' in mental representation and a machine's representation. The similar methodologies proposed in Shorts 360 can also be used in TV shows in the multiple camera editing setting. In the end, I wanted to also briefly cover some of the techniques that we developed to fully support this professional workflow. Like the example showing up here about a script writing workflow, creators often begin by brainstorming and then write stories down in a text-only interface with visual elements in their minds. They will imagine how this dialogue would be said by characters in existing movies. So to capture the tone and style of the movie in more detail, they will resort visual elements to bring a story to life. So the input to the system contains two parts. The first part is the specification of the fixed and variable attributes, and the second part is about the dialogue. So with this input, our script viz can respond to the queries and retrieve satisfying frames from the movie database. So let's consider a scenario a scripter wanted to write two people having an argument at a restaurant with our interface. The writer can use the interface to type in fixed attributes on place as restaurants, and she is not clear about the other setting. So the writers want to characterize Bob as confident and slightly arrogant, particularly in his interactions with Alice. So after considering various settings presented by the visualization, the writer opts for a nighttime ambience. This choice inspires addition of reaction sentence, and then she also specifies the genders, and he also find a scene in TED that really matches her mind. By steering these characters, she embodied herself to the characters and further refined the script. The writer can review the rendered results or change a specific frame at any time. So by offering this flexibility to partially shape their script visual aspects, ScriptViz encourages a more iterative and reflective writing process. In the final project is about a project that adds lyrics to a music video automatically. You will see a music video without lyrics seems a bit boring. So to make lyric video creation easy for people, we build a pipeline that automates this entire process according to 7 design principles that we proposed. So here is some of the final results. So back to the questions we proposed at the very beginning of my talk, can human and computers, what they need to do to better support our content creation? And also, I shared a lot of thoughts on different perspectives of this video creation. So I think the answer for machines and humans is that we got to collaborate together, but still there need a lot of efforts towards that. So the way for me to do it is about designing a transparent tools to automate the transitions from users' mental representation to machines presentation. It may involve the process like figuring out the problems in the human creation process, because only with that we can understand the user's intention and then help them get expected outputs and know what happened within it. And we also wanted to enable creators to make iterative improvements via reliable injections between human and AI system instead of a lot of trial and error. So in the end, I would like to back to this video that human made 140 years ago. Although there is only 20 frames and the content is very normal, but with a lot of efforts put by the creators, we can now see a lot of good movies within the screen. So I think in the near future, we can also utilize AI to better telling our story. Thanks.